Well, hi, good morning. Thanks so much for joining me in my shop. I'm going to be testing tubes today, all 5 of the tubes in that radio. If I'm going to test one, I may as well test all. And the one we're going to start out with is the rectifier tube, the 5Y4. This is set for 5Y4, but I'll just double check here quickly. 5 volts. Don't need to set that. Don't need to set the bias. 07030. Let's read that again. Try to read the right one. 0030P. 0030P. 25 on the meter English. E. For the plate, we're good to go. Now, pretty sure this tube's going to show up defective. That's certainly how it appeared in the radio. There we go. It's heating up. This didn't heat up in the radio. Oh. Sorry, turn this back there. You can see it heating up there. Son of a gun. Oh, this doesn't bode well at all for this radio. Okay, here we go. Any shorts in here? You should see that. There's a warning in the manual that on short setting 1 you'll see a full. So that's normal. Okay, we're on plate 1. Rectifiers and diodes. And the rectifier's up above this line here. So that's good. The other half. So this guy tests perfectly good. I'm stunned. And the other thing is I wasted probably 45 minutes going through my tube collection twice trying to look for a replacement. To my surprise, I couldn't find one. Well, there's nothing wrong with this tube. There's something wrong with the radio. Oh, that's good and bad news at the same time, isn't it? You know, I don't think this one was heating either. This is not what I thought it was. Let me pull out the output tube here. 6F6. 6F6. Yeah, I can read it there. Okay, so we'll set this up for 6F6. Just bear with me here. This will only take a 6, not 5. 6F6. Here we come. 6F6 right there. 6.3. Signal at 2. Bias 46H. 27345. 2 7 3 4 5 0610 34 F 830 when we go to test it. 830 up around here. Okay, filament is 6.3, tube in. Now this one comes to light. Also, lots of head scratching. If the rectifier is not heating, then there's something wrong with the rectifier heater circuit, which is a separate circuit right from the power transformer right to the rectifier filaments. And that whole circuit is just contained to the rectifier tube. So failure of the rectifier tube to heat in the radio indicates a problem with that circuit, but it shouldn't indicate any problems with the heater on here. The heater on here is heated from the same circuit. Oh, you know what? It's going to wait forever for that to warm up. It's heated by the same circuits that heat the rest of the tubes. Oh, that son of a gun! It's lighting up. I shouldn't be upset. It's a good thing. What's happened in this radio? Now I got one of these tubes in the right spot. Did they get swapped around? Oh, there's a chance these two tubes are in the wrong spot in that radio. Wow. Okay, well this is good. So let me just double check these numbers before I hit the button here. And 46H, right? 27345, 27345, 0610, 0610. I'll bet you those tubes are in the wrong spots. Jam. Well, that's a pretty sad showing there. A 6F6 should be showing up at least 830. So 830 is about double where it is now. What I do in situations like this is I double check the sensitivity of the bias setting in the English setting over here. We're not really using the English setting, I don't think. No, we are. So you see, a little wiggling doesn't do much. The reason I do this is because it could be the case that these settings are so sensitive that a slight miss on setting this could cause a big variation on the meter. So that's why if I test it too bad, I want to see it good. So I want to double check my readings, and so that's why I do that little sensitivity thing. It's never ever helped me. It's never once helped. Well, the good news is I got two good tubes, and the bad news is there's something wrong with that radio. But I'll bet you they're just plugged in the wrong way. And with luck, as luck would have it, nothing bad happened in the radio. So, what do you say? We give it a go. Let's give it a go. Let me just swing it around here. Well, first I better double check on these tubes. Tube. Now I can tell from back behind here pretty easily. I'll just change a bit of the lighting in my shop. If we look here, so you know the output tube is going to be connected to the speaker. The rectifier tube is going to be connected to leads from the power transformer. Okay, let's take a look with a close-up camera. I think I see the situation already. Anyway, the rectifier tube typically, I don't know if it's apparent on this one. Where to go? See, typically rectifier tubes don't have as many pins. They don't need as many pins, and it's just a waste of money for the manufacturer to put them in place. Another warning is these missing pins means there's terminals on the tube socket that are available for the radio designer to make connections to that don't affect the tube at all. They're just handy terminals, and often they do it. I mean often. And so when you look at the tube pin connection layout, you may be seeing a combination of wires going to the tube and wires having nothing to do with the tube at all. So at a glance, you can be fooled. I think I got it right. Okay, come on, let's take a look. Stop talking. Let's look. So I haven't found this exact kind of thing very often in my time doing this. So that's the one that had the rectifier in it, and this is the one that had the amplifier in it. So you see all those unconnected terminals there. Doesn't that scream out a hint at you? What else can I spot? So there's wires coming from the transformer like these ones right here. Where are they going? They're heading down to that tube. Okay, now can we prove the other one? Now we look at the other tube. Okay, we see things like this capacitor. I think this big one. Yeah, so you know these are all indications that this is an amplifier. Now, what I need real positive proof here before I go ahead and do this. See, there's like 1, 2. There's a terminal up in here, not connected. Terminal here. So that's definitely the rectifier tube. The tubes are in backwards, or incorrect, or swapped around, whatever. I have to admit, yesterday when they didn't light up, I thought, wait a minute, how do you get two? It's like pulling on a chain and having two links break. That's not going to happen. It's just going to be one link, right? So you find two links broken. What's been going on with that chain? And another thing I'm going to admit to here, but don't tell anybody, I left this radio on after yesterday's session until I came back just a few minutes ago. And when I was reaching in to pull out the rectifier tube from the wrong spot, I felt some heat in this tube. I go, oh my gosh, the set is on. Shameful, eh? The things I admit to in my videos. Oh boy, so we're going to put the rectifier tube in here. I think he's happier. You know, there's another logical way of looking at this too, which is they kind of want to put tubes of a feather together. So this audio tube, which why is it not going in? There it goes. You just, you know, not always, but you kind of expect this to be right next to the detector tube that's firing the audio into it. You wouldn't think they'd stick the rectifier tube here and then wire the audio around and in. I mean, it just doesn't make logical sense. So probably what would have made more sense is for me to check. Now, how many other tubes are in the wrong spot? What a flash. What a flash, Jim. So this one's probably a 6SA7. 6K8, I think that's possible there. And this should be a 6K7, shouldn't it? Didn't I have a tube? Wait a minute, I got a tube thing here on the bottom plate. Yeah. Oh, okay, no doubt now. If there be no doubt. Yeah, there it is, the 5Y4 in the corner. 6F6 next. 6Q7, supposed to be under a can, that would be this one. 6Q7, 6K7, 6K8. So, okay, so the 6K8 is here. That's got to be a 6K7. It's got to be. This should be then a 6Q7. Now, I said I was going to test all these tubes, and you know, that's generally a worthwhile thing to do, but I'm not gonna. I'm gonna let them play in the radio here. But let's just see if I can verify that this is the right tube here. In there pretty. I hate pulling on the glass bulb. I brought another tube in here to test, which I thought would be interesting. I've got to take this off first here. Tubes are really jammed in there. 6Q7. Pulling these out and putting them back in. Oh yeah, it's jammed in there because this is bent over. That's what's happening here. When I was doing the inspection underneath, I never looked to see if there's anything really wrecked up under here. Now, maybe this tube wasn't here, and maybe this thing was knocked right over and somebody's pushed it back and shoved the tube in and sold the radio. So I'm looking under there now. And no. I don't think this little thing has caused anything serious, in fact. Eventually I'll be pushing it back, I'm pretty sure. And why wouldn't you do that right now? This is how you do a chiropractic treatment on a radio. Okay, see this very particular hand position here. Okay, so we apply pressure and then it doesn't move. Look at that. Chiropractic replacement of a part in the radio. You saw it. Hey, I've been watching chiropractor videos on the internet. What can I tell you? For some reason I enjoy watching people get their back cracked. Now, I think if my life had gone differently, I would have worked myself into being a chiropractor. Hey, I am a chiropractor. Are we ready to turn it on? I think so. I think we reached that point once again. Now, wait a minute. Now, I tested this guy with a high voltage supply. Why would I want to repeat that just because I moved these tubes around? The only reason would be because somehow putting the output tube in its place has initiated a short. Nah, you know, the chance of that is really small. Still going to rely on the dim bulbs here. so I shouldn't be too worried. Volume is down. Okay, volume is up 20%. No antenna. So this time it's going to produce its own B+. This will be the first time it's doing that. Why don't we read it? Why don't we read the B+? And just for fun, we're going to use another meter, a new meter I've got. So this is a meter that's, I'm going to do a little program on this once I get a little more comfortable with it. This is a meter that has a display of the waveform on it, which I've been fiddling around with. But it's also just a regular voltmeter also. This might look good on my videos because it's a backlit screen. Okay, now where would we test to? One of these I'm going to want to clip to ground with my newfangled all soldered up clip leads. The other one I'm going to want to put right on the positive side of one of these, right here, I think, right here. I'll go right here. Question is, should I clip it? Yeah, get my hands free. Keep my hands free. So this is set to DC. It's an auto ranging voltmeter. Go on here. There we are. Now I've got this hooked up backwards, don't I? I've gone and put the negative here. Let's do it right. So we get a positive reading on the meter. To hook this up backwards with one of my older vintage VTVMs, that might not be a very good thing, because they're plugged in the wall. There could be a grounding issue, but with this kind of meter, it's just floating out here with batteries. It's not a problem. Okay, AC safe. Switch is on. No reason to repeat that. We're ready. We're ready to go. Okay, now can you see the light bulb? You can just see the tip of the light bulb here. I just move this over a touch. Now again, this time it should come up fairly bright because it's got two more tubes to power now. Come up bright. The brightness is actually a current rush into cold heaters. Whoosh, the light comes up. The heaters warm up, the light goes down as the current flow reduces. Once the rectifier heater is heated up, it will start to conduct current and generate the high voltage. The high voltage will make it out to all the tubes, and all the tubes will start conducting, and we'll see the light get brighter again as the radio tries to draw more and more current. It actually does draw more and more current. So I got that. It should go. The light should go on, down, and you see it come back up. And as it comes back up, we should start hearing stuff come out of the speaker. We should not see smoke coming out of anything. Smoke, flames, and you should not hear me screaming as I run out of the room either. Here we go. This is it. Very bright. Very, very, very bright. But I'm patient. I'm hanging on. I'm hanging on. Okay, I think it's dulling down. Tricky to see. It is definitely dulling down now. Why is it showing negative? Pourquoi? What was it beeping? Overload. You could just change scales automatically. So we're reading a negative there for reasons I don't understand. Well, what stupid thing am I doing? Oh, there's the stupid thing I'm doing. Got the plugs here back. I said let's do this right. Didn't I say something about that? Okay, I'm not panicking here because the dim light is not fully bright. Why beep at me? Why don't you just auto range yourself to where you want to go? 50 volts on the B+. At least I believe that's what I'm measuring. That's nowhere near enough to hear. Dim bulb is still dimming. Now let's just take a peek up here and see. For sure this. mirror. Oh, my mirror's in another room. Okay, I'm going to rotate this very carefully. Get a look at the tubes here. Well, you know what? The heater voltage is probably so low, it's not even bright enough for me to see. Let's see if I can feel the heat. This is ice cold. This one's not. This is warming up. Can't feel the heat. Okay, so what we'll do is we're going to raise the supply voltage to the radio now. Just like this. The way we're going to do that is screw in another dim bulb and give it more power by running through two bulbs in parallel. Any reason not to do that? Power drain. Power drain is 8 watts. I mean, there's nothing happening here. $52 volts supplied to the radio. It's just stupidly low. Okay, I'm going to screw in this light bulb and everything's going to go up, and this guy's going to go up to 150 or something like that, I bet. Here we go. Hum has come. Okay, lots of things are happening now. You can hear tubes clicking as they heat. Okay, our supply voltage now is 102 volts. That's enough to make the radio work. Let's turn the volume up. Come on, radio. Okay. Is that volume? Oh, here's the volume. Check it out. Antenna. That's a lovely sound of interference in my shop. Well, this radio's working. Oh my gosh, really? Just as it is? Can we receive something? Interesting question. Let's give it a try. Now it's still under restricted. I don't have this on full power yet. Okay, and this is the antenna. Right now the antenna feed into my shop is switched off. So when I hook this up, all we're doing is hooking up a big long coax cable, really. That's what we're doing here. Ground. Antenna. Let me get it in the back here. Okay, so I'm going to run down, I'm going to flip a switch at the antenna head and turn the antenna on in here, and I will be back. Okay, fortunately I'm out of the room, so I don't even know what happened. But you may have heard it change when I snapped the switch. Now there's piles and piles of buttons on the front of this radio. I don't know what they mean. We may have it switched to phono right now. Hey, let's tune it and see what happens. Ticking change pace there. Well, I'm not hearing any radio action. Let's bunch of push buttons here. For safety's sake, I'm going to remove this now because we know what the B plus is running around. That's kind of interesting, eh? I removed this meter and it got louder. Just a meter. Careful, don't touch that. So, off, I'm going to guess, phono. This would be AM, I'm guessing. It's the same ticking. The ticking is a radio thing. You wouldn't expect that in phono. Wow, isn't that interesting? I just switched off the antenna and the ticking went away. Does that mean it's just on the antenna? Let's carry on. Tune some more. You know what I feel? I feel a signal generator coming on here. Let's try another band switch here. I don't know that that's a band switch, frankly. This is only a 2-band radio. Think about that now. 2-band radio. So these must be all presets for AM radio. Maybe shortwave too. These ones aren't mechanical. They don't push the pointer around. They just select different sets of coils in here. Well, the push buttons wouldn't be for shortwave. They would fix this for AM. They would arrange this for AM. This is AM. Let's go way out on the far end here. Okay, how much you want to bet that is a phono? Can I see if I'm looking at these wires quickly? Where's the phono jack? Those weird multi-phono jacking stuff on the end of this cable up here. Okay, so I'm not going to get too far here like this. So then, if that's the case, that these are pre-selects, there's 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, phono, VFO, off. It's got to be like that. So if I were to build this radio, I would have on, off, phono, VFO. I'm not the guy who built this radio, of course. Get nowhere with this. Okay, change of approach. Goodness knows what's going on that antenna. I'll hook this up to the signal generator over here. Signal generator is putting out a signal at 1500. Let's put it more in the middle of that band here. Turn it up. That's a medium strong signal. Any radio should receive that. About the middle of the band, the capacitor. If we look at it, the capacitor's right, roughly in the middle of the band. And the pointer is roughly in the middle. Oh, there's a pointer. What am I doing? Let's go there. Okay, so we're right around 11. Volume up. Hello. Come in. Now, for all I know, I got this switched to phono right now. Okay. Well, let's try pushing this button here. Let's just try pushing this button. Nobody home. Okay, well, these coils kind of line up with these switches. These two, they don't line up with any coils. So maybe these are the phono and the VFO. Let's try that. Line down. This would be, you can't even see what I'm doing, can you? There, up here. This. So these two, see these two switches? There's no coils over here like there are here. So maybe these are the phono and VFO. Phono. Okay, that could be phono. VFO. Okay, that could be phono. I'm not getting too far here. Switch strategy. We'll try feeding a 455 kilohertz IF signal in through the IF and see if that comes out the speaker. That sounds like fun. Okay, put a very high signal into the antenna at 455. Make sure the radio's turned up, which it is. Okay, now we'll turn this down. I'm going to feed it right into the grid cap. On the 6 on this tube. Actually, you know what? We'll do the finger steady first. Finger steady. Okay, first turn down the volume. Now, using the free hand in your pocket rule, which I follow actually. Hey, how come we hear nothing? Okay, right on the audio. Okay, we can hear that. Let me turn it up. Doesn't sound great, but if a little bit of audio makes it here, we should hear it coming out the speaker. Here? Okay, so maybe it's switched in phono right now. And what is this thing, by the way? Well, this switch is associated with this cable. Don't know. But I will throw it eventually. So we'll push the other push button here, thinking that we're switching to VFO. VFO. Nothing. Okay, well, we got some fixing to do. That's really a little bit disappointing, actually. It's that dead. Now, you know, maybe I got dead tubes in here because I didn't test them all. They're back to tube testing at this point. Or we give it full power. We give it full power, that'll raise the input power to 120 from 100. You know, 100 is enough. 100 is, in my experience, that's enough. This guy should be working. So what if we push one of the preset buttons, which we now assume is AM radio. We push the preset button, any one of them, and then we'll scan through the signal generator and see if we can find what it's preset to. And then also, by pushing these preset buttons that control these coils, that for sure puts the radio into radio mode and not in phono mode. Okay, I like it. Here we go. Any one. Pick that one. Okay, it's in there. And just make this a little bit like that. So we're somewhere in the middle. Well, it doesn't matter where the VFO is tuned, Jim. Let's just go hunting. Starting above the AM band, putting it on full power, any radio would receive this loudly. Hey, I hear it. I hear it again. Now let's see, that's 11, that's almost 12? 1 megahertz. Not quite. Here, there. Remember, I'm ramming a huge signal into the front end of this radio. It wouldn't be surprised if it's... Now that sounds more like it. Some rattly sounds in the speaker. Let's keep going. Okay, I gotta change pans here. Now coming up from below. There's 455. How come we didn't hear it before? Oh, I didn't have the center button pushed. I never knew where the VFO is. We can find the VFO now. Okay, so we should be able to hear that sound no matter which one of these buttons I pick for these coils. That's my theory. Here we go. Now, this next button, things may be different. No, next button, going to be different. Either VFO, that's the tuning, the rotating tuning, or phono. VFO, come on. Oh, the 455 sound went away. See, that's suggesting to me that what's happening is either the radio is no longer hearing what's coming out of the radio, it's listening to the phono, or voltages have been cut off to some of the radio tubes to quiet them because it's in phono mode. Let's try this. There it is again. Okay, so now we're in VFO mode, I'm sure. Yeah. So you can even see a tuning effect, some weird tuning effect. I mean, I was supposed to tune 455 with the radio. So we're about midway. Well, where are we? Where are we on the dial? On the dial, we're at 750. Okay. 750 it is. I think there's a real basket case for alignment, I believe. This guy's really in need of it. The reason I say that is as I tune down through the signal, it seems to come up and go down, come up and go down. It's not a nice curve. Okay, so how do you like that, eh? Who'd have thought? You just never know when you start these guys, working on these guys. So I'm going to make some decisions around what to do with this radio. This is my own personal radio. It's working. Doesn't seem to be working very well. Wait a minute. Wait one cotton picking minute. Shame on me for saying that. I should never say that. Never, never, never say that. Okay. What I just realized is there has to be a setting here to flip this over to shortwave. One, two, three, four, five, six, seven, 8 buttons. Subtract 1 because this is the on-off. 7 buttons. 7 buttons. 5 coils. 1, 2, 3, 4, 5. Leaves 2. Well, I keep thinking 1 is for phono. The reason I think that is because there was that plate with the phono plugs on the back. I mean, what else could that be for? The only other way you would get at phono would be to throw this switch. Sure enough, that's what's going on. So none of these are for turning on the phono. Hey, how come it went so quiet? Wandering a bit. So that means one of these is AM VFO, the other one is shortwave. Ha! We know this one's AM? No, we don't know that yet. Yeah, we do. Because right now we're listening to AM on the antenna. So we'll assume, okay, so this one's short wave. We'll push this in and see what we can find. Okay, let's try it. Okay, now on the front we're up around 8 megahertz. Let us go to 8 megahertz. See what we get. Very strong signal. Working on both bands. With this kind of signal, this level of signal being fed right onto the antenna, and that's all you hear coming out of this radio. I mean, we're still on restricted power. And I plan to leave it like that for now. So that drives down the volume. The volume is full tilt here. Oh, you know what? It isn't. So this got to be tone. Okay. Oh yeah, baby. Baby, she's working. Here you can hear a little bit of the sound. To me gets hard when you turn it up. Right there. Well, that's definitely some harmonics or some other kind of distortion coming into the picture. Well, okay, if we got this kind of volume, hey, let's go back to the antenna. Let's see what we got. Okay, just don't want to get. I don't want to have an accident here. I gotta kind of reach around funny, like this. Incidentally, anytime I'm making connections with leads, like the BNC connector I just put onto my antenna, I'm well aware that there's a shock hazard while I'm holding one thing and about to touch something else. I'm totally aware of these things all the time. So I'm usually taking small steps to ensure I don't get a shock in here, which I don't talk about and would not be apparent at all to those of you who are watching. But I'm quite cautious about getting a shock. If I'm going to get one, I want to get a good one, right? Okay, so we're on the outdoor antenna. I kind of lost my head there. Turn it right up. Is the outdoor antenna off? Well, it's not showing up as Mr. Super Sensitive Radio, is it? I sure got this turned right up. Tone up. This tone control may be okay, so I can hear a little bit. It's the same little bit all the way across. Put this guy on full power. So it's been running here for quite a while on 100 volts. What's another 20? Another 20. What is another 20? Another 20. Oh, I'm about to make a terrible, terrible mistake with this meter. I just came that close. Not a terrible mistake, or a terrible mistake, a mistake. It's a mistake to grab a meter like this and whip the control around to where you want it. Now the reason is, with this meter, I'm going past these amp settings. From off, you go through amp. That essentially turns the meter into a short circuit. That's one of the reasons why these leads, you have to unplug them and replug them somewhere else. That's what would save me in this case. I don't think all meters are built like that. But there are many warnings in the manual for this. Do not have the leads on when you're rotating this control. So I will follow the instructions here. So the only way to turn it on is to pass right through those amp guys. Okay, so we got 216 volts of B+, and when I put this on full, this will probably go up to 300. I'm going to guess. Everybody take a guess. We're going to go from 100 to 120 supply voltage. 292, that's my guess. 292. Okay, there's something making a sound. Tone rate down, the sound disappears. Volume has no difference. That's kind of weird. I don't like that sound. It really sounds like something frying, cooking, breaking down. I think it's coming out of the speaker though. There's something frying or breaking down in the circuits that lend audio to the speaker. Oh. Are we nervous? I'm nervous. 252, I was way off on my guess. Anything getting hot in this radio? Okay, so I'm going to touch the transformer. Not really. And touch the speaker as best I can. I can't really get my hand in there safely. No sign of heat. So I think we're okay to leave it like this. Wow. Did I? Okay, we're going to leave that sound there, because I think when I turn this down, the sound disappears. Whatever's happening is still happening. I don't know. Tune, baby. 8, 9, 10, 12, 14. Okay, if we're going to hear something, it's going to be up in this area here. Volumes are off. We're just getting the most we can out of it. I don't think we're going to hear anything in here. Yeah. Okay, switching to AM VFO. That sounds pretty good. That's around 8. No, this is 740, I think.
Plug in. 50 seconds from now. Check traffic along with your extended weather forecast.
CB News Time 1020. Another rewarding moment from Rexall Pharma Plus. Vitamins, toothpaste, shampoo. Wow, you got everything I want.
Son of a gun.
And I do.
Because I always want to make you happy.
Or is it because you wanted the 40 air miles bonus? $40.
Well, more so the other thing.
Sure. This Friday to Sunday, get 40 air miles bonus miles when you spend $40
Son of a gun.
more on almost everything in store.
This radio works.
For details. Rexall, your pharmacy, your way.
What if you won this Friday's Lotto Max jackpot of an estimated $60 million? Would you stay inside and hide from the rain? Or would you head to the coast of Spain? Would you let winter get you down? Or would you head to Australia and turn things around? Would Friday be spent surfing the net? Or would you make it a great day you'd never forget? Dream bigger. This Friday's Lotto Max jackpot is an estimated $60 million, plus an estimated 42 additional prizes of $1 million with Max Millions.
News Time 1021.
Now time for
680.
traffic weather together on the ones and checking that drive. It's Eva Francescato.
Well, this report is brought to you by Infinity of Willowdale.
So
Some
scary
good
here.
news. Yay,
Okay, hold on.
eastbound
Less scary. Let's just turn this around here. So in the middle of turning this, one of those leads could pop off. Anything at all could happen.
On the South 404 DDP from the south of Finch all the way through to those problems approaching
This is the traffic report
and
from
then once
Toronto.
you get past that issue, it does slow down from Don Mills to just south of it. On the southbound 400, no major issues to report.
680.
There looks pretty good. Southbound 427 is still quite slow going from south of Bloor and the Express to the Gardner ramp. We have some issues on the shoulder. Westbound on the Gardner
Pointer is
Expressway, I'm spotting a
from
delay
the-
now from
see?
approaching Bathurst.
Don't be fooled by these
Westbound
things.
Strawn, it looks to be just volume related. But we
Virtually dead on 680.
Cruise through there. If you're on the West 401, a delay
Let's go to
through
640.
Kennedy and the collectors. Warden.
claim that if they give up, instead of keep their ability to populate the woman and things like that. But after they gave up, ended up killing all the men and taking the women.
Killing the men, taking the women. You know what taking means. He's not saying raping, but that's what he means. Some of those women remain in the custody of the Islamic State captors, and they've been turned into sex. Yeah, I'm sorry, his numbers get for much are good.
Well, this radio gets really good marks already.
When they acquired him, was the fact that he did so well against those teams. He did. His numbers against the Yankees were built. Red Sox numbers, not so bad. Yeah.
Amazing. I can't believe it. Okay, let's shut the power off here. Okay, now we know the whole story with this radio, and now I'm ready to do or not do something with it. So I say, well, there's a lot of big ugly capacitors in this thing. Like this guy, this guy, this guy up here. This one here, for no known reason, is sitting there. Let me just improve my safety here by pulling that right out. So in terms if I were to change the potentially bad capacitors in here, there's 1, 2, 3, 4, 5, 6. Let's do that. 7, 8, 9 capacitors, 10. So there's like a dozen capacitors to change in here. Probably about $20 worth of capacitors to go into it. Why not? I can only make it work better. It seems like its sensitivity on shortwave is poor. That's not too surprising. That could be a tube issue. Nothing to do with these capacitors. I could test some of these capacitors. It still has the original 10 hooked up here with a 10 in parallel. Maybe we could set this correct and just have a 10 in here. And you know what? I could test this right now, except the radio's been on. There's charges in it. I'll leave it alone. Okay, well, I think what I'll do is I'll think about it, what I'm going to do with this radio, and I think it's got a really, really cool look. So I think it's really worth getting it sorted out. Okay, that's it. And that's it for today. Fantastic. Hey, thanks so much for watching.